Let's look at how to multiply two matrices. So first we'll start off with an example. So these are the two matrices that are getting multiplied. First you guys need to understand or not understand, observe the order of the two matrices. What is the order? This is 2 by 2 and this is 2 by 3. Now let's see the operation of multiplication. Make your observation. Make your observation. Look at the red numbers that are coming up and look at the final result. Look at all of it. Guess what numbers will turn up? Guess what is the final answer? Look at the order of the resulting matrix. Right? Okay. So before we do the actual multiplication, let's answer a few commonsensical questions which we have to have. Condition that needs to be satisfied before multiplying two matrices. Condition is the inner dimension has to be same. So the question is, what is inner dimension? So let's look at an example. We are looking at an example wherein the multiplication is possible. So these are two matrices. Those are your orders. The inner matrix has to do with this set of numbers. Those are your inner dimension. So within this two, if I change the order, you can see over here, I have flipped the order. It's the same matrices. I flip the order. But here, the inner dimension are not the same. So what happens? So we can see that we cannot multiply this. Okay, so 4 and 3, they're not the same. While 5 and 5, they are the same. So we are able to multiply. Now, what is the order of the resulting matrix? So in this case, we can see that it is 2 by 3. So do you think matrix B, is it influencing the order? Let me give you guys one more example. So I'll run it fast. So guess the results over here. Take a second and guess. Guess the next three. What is the final answer over here? Yes, 15 plus 42. 57, right? Okay, we are here to look at the order. What is the order of the resulting matrix? We have 1, 2, 3, 4 columns, 3 rows. So I'll give you guys a clue. It is influenced by the rows, number of rows are influenced by a particular matrix. Number of column is influenced by particular matrix. Think of it. Yes, the number of rows are influenced by the first matrix while the number of column is influenced by the second matrix. So basically, to put it in a very simple manner, it has to do with the, can you guess? Outer dimension, right? You guys are right. So this is to do with outer dimension. Defines or influences. Defines the order of resulting matrix. Now, in general, if I have vector A and vector B with this particular order, so you can see the inner dimension is the same, the resulting vector will be n cross p. Okay, so keep all of this in mind. Now, let's move on to the actual multiplication. How do we multiply? I hope you guys made a very good observation. So let's put it in word form. To get the I comma kth element of I C I K of the matrix C, we take the ith row of the A and the kth column of the B, multiply them element wise, take the sum of all these products. So first thing first, let me put it as an example. So we have the matrix A to be 1, 2, 5, 6, and matrix B in this example is 0 0.5, 0, 2 and 5, minus 1 and 2. Now, the resulting matrix will be of the dimension 2 rows and 3 columns. So the 2 comes from here and the 3 comes from here. 2 by 2 and 2 by 3, right? So that's how you get 2 by 3 over here. Okay. Now, this is your C11, this is your C12, this is your C13, correct? This is your C21, C22, C23. This has to be very clear. Now, C11 comes from first column, first row, first column. Multiply them element wise. What does it mean? Take 1 and 0 0.5, multiply them. Keep the result in mind. 2 and 0, keep the result in mind. That I have made. We can see clearly we have 0 0.5 over there. And 0 0.5 plus 0 is your resulting answer over here. So this is basically 0 0.5. Next, take the C12 represents first column, first row, second column, first row, second column. We can see that clearly, element wise multiplication again. So let me kind of color code this off. This and this, right? The same patterns. While the other end, we have something like this. Okay, those are the ones which are getting multiplied. Right, so again, the same set of operations. So we have 1 into 2, 2 into 5, 2 and 10, the total is 12. Then 1 and minus 1, 2 and 2, so minus 1, 4, answer is 3. Next, we have C21, that is second row, first column. 5 into 0 0.5 is 2.5, 6 into 0 is 0. So answer is 2.5. Then we have 5, 6, that is the second row, second column. C22 means second row, second column. 5, 6 getting multiplied with 2, 5. So 5 2s are 10, 6 5s are 30. And the result over here is 40. And finally, we have 5, 6, minus 1 and 6. 5 into minus 1 is minus 5, 6 into 2 is 12. And the sum is, yes, 7. And that's our final answer. Okay, guys. So let's see that. Array, not 0 0.5, 12, 3. 5, 12 and 3. 2.5, 40 and 7. 2.5, 40 and 7. That's correct. So let's concrete the idea with this example. Just try it out. Element wise multiplication, take the sum 17, write it down. First row, fourth column, so C14 is what we will get. So again the outer dimensions are making the influence, right? Okay guys, and finally we have the answer to be this. Yes, and you guys have to pretty much copy everything. You can just do it on your own, so you need not copy all of this, but yeah, till the end of the example here, till here you guys have to. After that, what you guys do, it's left to you guys. So you can write, I think, one or two of it. So maybe like C13, what does it mean? Then C21, what does it mean? I think 1 to 1, I think you can write C21 and C13. Just write this too so that things are clear, you know. So all of it comes from this slide. So this has to be written.